November 14, 1981. The Guyuk Gap, North Atlantic. Depth 400 meters or 1,300 feet. Ambient noise, low-frequency reactor hum. The ocean at this depth is a black, crushing void. It is a place where biology ceases to function and physics begins to warp under the weight of 1,000 atmospheres. But inside the hull of the Soviet Project 705 Lira, known to NATO as the Alfa class, the air is warm, smelling of recycled oxygen, cheap tobacco, and the faint, metallic tang of ozone. This is not a submarine. It is an underwater spaceship, carved from expensive non-magnetic titanium and powered by a radical liquid metal-cooled reactor. The Alfa is the crown jewel of Soviet naval engineering. It is designed to do one thing: outrun the apocalypse. Let them listen, comrade. By the time they calculate a firing solution, we will be in the next grid square. The Americans build bathtubs. We have built a bullet. Captain Valery Petrov leans against the periscope stand, watching the glowing green sweep of the sonar display. He is a man of supreme confidence, a titan of the deep. His doctrine is simple. Speed is life. The American torpedoes of the previous decade, the Mark 37s, were slow, lumbering beasts that wheezed along at 26 knots. The Alfa can sprint at 41 knots without breaking a sweat. In the mind of the Soviet Admiralty, the math is absolute. If the weapon cannot catch the target is immortal. The arrogance is rooted in fluid dynamics. To catch an Alfa moving at flank speed, a torpedo would need to travel at nearly 60 knots. At those speeds, water behaves less like a liquid and more like concrete. The drag coefficient skyrockets, and the energy required to push through the medium expands exponentially. The Soviets believe the Americans are limited by the laws of thermodynamics. They believe a battery-powered motor simply cannot generate the torque required to close the gap. They are wrong. The mood in the Command Industry Center is relaxed. They know an American Los Angeles-class attack sub is somewhere out there lurking in the blind spots of the thermal layers. But to the crew of the Alfa, the American boat is a dinosaur, a steel tube relying on stealth because it lacks strength. The Soviet doctrine relies on brute force and the laugh that comes when you realize your enemy is fighting a war that ended 10 years ago. They view Western technology as fragile, overcomplicated, and prone to failure in the harsh reality of the Barents Sea. Hydrophone contact. High-pitch whine. Bearing 180. Distance rapidly decreasing. The sonar operator adjusts his headset, a frown creasing his forehead. He expects the low, rhythmic thumping of a submarine propeller. Instead, he hears a sound that defies the catalog of known acoustic signatures. It is not the chugging of a diesel engine. It is not the hum of a reactor. Captain, contact. High-speed screw noise. It sounds like a chainsaw. The laughter in the control room dies instantly. The sound coming over the speakers is not the clumsy churning of a Mark 37. It is a high RPM scream, a mechanical shriek that tears through the water with terrifying authority. It is the sound of an engine that doesn't care about drag coefficients. The paper tiger theory is evaporating in the cold Atlantic water. Something is out there, and for the first time in the history of the Cold War, the hunter in the titanium shell realizes he might be the prey. The Phantom has arrived. Time T-120 seconds to impact. Speed 42 knots. Hull vibration critical. Acoustic environment deafening. The command to accelerate to flank is usually a moment of triumph for an Alfa crew. It is the moment they engage the cheat code of naval warfare. The liquid metal reactor dumps thermal energy into the turbines with a violence that standard pressurized water reactors cannot match. The propeller bites into the Atlantic, and the submarine surges forward like a muscle car on a drag strip. The hull groans under the G-forces, the deck plates shudder, and the sensation of speed is visceral. At 42 knots, they are faster than most surface warships. They are certainly faster than any torpedo known to Soviet intelligence. But the physics of the ocean are cruel. When you move a 3,000-ton titanium cylinder through water at highway speeds, you cease to be a submarine. You become a deafening, rattling, chaotic event. You are blinded by your own flow noise. You are running in the dark, screaming at the top of your lungs. "Maintain 42 knots. Hard right rudder. We will shake it in the thermal layer." Captain Petrov shouts over the mechanical din, his eyes locked on the depth gauge. He is executing the standard Soviet evasion doctrine: go fast, go deep, turn hard. It is a maneuver designed to break the lock of a primitive seeker head. In the 1970s, against a Mark 37, this would have worked. The torpedo would have lost the acoustic trail in the wash of the submarine's own wake, spun in confused circles, and eventually run out of battery. But the sound in the headset does not fade. The high-pitched mechanical whine, the chainsaw does not drop in frequency. The Doppler effect is the judge, jury, and executioner here. If the source of the sound was falling behind the observer, the pitch would drop. It would stretch out, becoming lower and fainter. The sonar operator is praying for that drop. He is waiting for the physics to confirm that they are escaping. Instead, the pitch is rising. The frequency is compressing. The wavelength is getting shorter. The object is accelerating. Contact speed, 55 knots, increasing to 58 knots. Range 2,000 yards. Status, active pinging. Panic is a cold fluid. It starts in the stomach and moves to the extremities. The sonar operator rips the headset off one ear, his face draining of color. The sound has changed. It is no longer just the engine noise. A new sound cuts through the water, terrifyingly rhythmic. Ping, ping, ping. It is the active sonar of the pursuer. But this is not the slow, methodical search of a ship's sonar. This is a rapid-fire interrogation. The torpedo is lighting them up. It is pulsing sound waves into the void, waiting for the echo to bounce off the titanium hull and calculating the solution. "It's going active, Captain. The interval is dropping. It sees us!" Petrov freezes. A torpedo moving at nearly 60 knots should be blind. The flow noise over its own sonar dome should be deafening. It should be impossible to hear an echo return at that velocity. The American weapon is violating the rules of engagement. It is running a marathon at a sprint pace while solving a calculus problem. The Alfa banks hard, the deck tilting at a sickening 30-degree angle. They dive past maximum operating depth, the titanium ribs compressing under the immense pressure of the North Atlantic. They are trying to hide in the noise of the ocean floor to blend into the rocks. Torpedo behavior, serpentine pattern, lock status, reacquired. Distance 800 yards. The torpedo does not fall for the trick. On the tactical plot, the green dot of the weapon does not move in a straight line. It snakes. It performs a sinusoidal search pattern, weaving left and right, sniffing the water like a bloodhound. It is detecting the specific acoustic signature of the Alfa's screw, the cavitation frequency that is as unique as a fingerprint. The crew of the Lira realizes with dawning horror that they are not fighting a dumb munition. They are fighting an autonomous robot, a machine that has been programmed with the specific intent to kill them. It doesn't get tired. It doesn't panic. It doesn't care that they are doing 42 knots. At this range, the time to impact becomes a math problem that the human brain struggles to process. The relative velocity is closing at nearly 30 feet per second. The submarine is 100 meters long. The torpedo needs to hit a moving target in a three-dimensional space where both objects are drifting. The torpedo's guidance computer is making 10 corrections per second, adjusting its fins by millimeters to account for current salinity and the desperate maneuvering of the target. "Launch countermeasures!" Petrov screams. Capsules of effervescing chemicals are ejected from the submarine's hull. They explode into clouds of bubbles, creating a dense wall of noise designed to confuse sonar. It creates a false target, a ghost submarine made of sound. The green dot on the screen wavers for a microsecond. The crew holds its breath. The torpedo heads toward the decoy. A glimmer of hope. The paper tiger is confused by a simple magic trick. Then the green dot turns. It ignores the decoy. It ignores the wall of bubbles. It snaps back onto the bearing of the Alfa with a mechanical ruthlessness that feels personal. The weapon has logic gating. It analyzed the decoy, determined the Doppler shift was wrong, that the decoy wasn't moving, and rejected the data. It reprioritized the moving metal object. The atmosphere in the bunker shifts from combat stress to existential dread. This is the moment the Soviet worldview collapses. They built their entire naval strategy on the belief that American technology was soft, that it relied on delicate electronics that would fail in the chaos of war, that their sheer speed and titanium armor were unbeatable trump cards. Now, staring at the sonar screen, they see the truth. The American technology isn't soft. It is an apex predator. The Phantom isn't a glitch. It is a technological singularity that has rendered their billion-ruble submarine obsolete while it is still alive. Sound high-pitched scream, terminal phase, range, 200 yards. Light red emergency strobes. The chainsaw sound is now audible through the hull without headphones. It is a vibrating drilling noise that rattles the teeth of the men in the control room. The hunt is over. The execution begins. Petrov looks around his command center. He sees the fear in the eyes of his men who were told they were invincible. He realizes that the ocean is no longer big enough to hide in. The Americans haven't just built a torpedo. They have built an inevitability. The final seconds are not filled with heroic commands. They are filled with the realization of a massive calculation error. The arrogant Titan has been checkmated by a tube of electronics that cost a fraction of his ship's price. The sound of the screw reaches a crescendo, a banshee wail that drowns out the reactor, the shouting, and the prayers. Silence. Location: Naval Undersea Warfare Center, Newport, Rhode Island. Atmosphere: sterile, fluorescent. Classified. Object: Mk-48, torpedo cutaway section. Scent: hydraulic fluid and eau de Otto, nitrated ester. To understand why Captain Petrov died in the dark, we must leave the crushing depths of the Atlantic and step into the fluorescent sterility of a laboratory in Rhode Island. Here, the wizards, the American naval engineers, were staring at a problem that looked mathematically impossible. Intelligence reports regarding the Soviet Lira, or Alfa class, were terrifying. The Soviets had built a submarine that could dive to 700 meters and sprint at 41 knots. The existing American torpedo, the Mark 37, was an electric-powered relic. It was a battery on a propeller. It had a top speed of 26 knots. In a stern chase, the Soviet Alfa could simply outrun the American weapon, leaving it to run out of juice in the vast, empty ocean. The Soviet Admiralty knew this. That was the source of the laugh. They believed the Americans were wedded to the silence of electric propulsion, and that physics dictated a battery could never be energy-dense enough to catch a titanium rocket. The Soviets were right about the batteries, but they were wrong about the American willingness to embrace a different kind of power. The engineers in Newport didn't try to build a better battery. They built a chemical demon. Enter Otto Fuel II. The breakthrough was chemistry, not electricity. Traditional combustion engines require two things: fuel and an oxidizer, usually air. Submarines and torpedoes don't have access to air. Carrying tanks of compressed oxygen is heavy, dangerous, and voluminous. It wastes space that should be used for the warhead. Otto Fuel II is a monopropellant. It is a distinct, bright red, oily liquid, a nitrated ester that carries its own oxygen within its molecular structure. It doesn't need to breathe. When ignited, it doesn't burn. It decomposes violently. It releases massive amounts of hot gas instantly without requiring a single cubic centimeter of external air. It is stable enough to sit in a tank for years, but volatile enough to generate the horsepower of a Corvette inside a tube the diameter of a pizza. This was the anomaly the Soviet sonar operator heard. The Mark 48 wasn't humming with the polite whir of an electric motor. It was screaming with the violence of a swashplate piston engine. This engine, an external combustion marvel, took the high-pressure gas generated by the Otto fuel and drove a complex, localized transmission. The result was 500 horsepower packed into a 21-inch diameter frame. It allowed the Mark 48 to achieve speeds in excess of 55 knots. Some sources suggest significantly higher in deep water. It didn't just close the gap, it erased it. The Soviet speed advantage was mathematically nullified by a red liquid that smelled like almonds and death. The Soviets thought we were playing chess with batteries. We were playing drag racing with liquid explosives. The Mark 48 doesn't swim. It flies through the water. But speed is useless without control. A fast torpedo is just a dumb rocket if it can't find its target. This leads to the second fatal assumption of the Soviet doctrine: the belief that the torpedo was a fire-and-forget weapon. The Soviet commanders assumed that once a torpedo left the tube, it was on its own. It had to rely on its own tiny onboard sonar to find the target. Since a torpedo is small, its sonar dish is small, roughly 18 inches. A small dish means poor resolution and short range. Therefore, the Soviets believed that if they could just get far enough away, the torpedo would go blind. They didn't see the wire. Component: copper guidance wire. Thickness: human hair. Length: 10 miles. Data transfer: two-way. The Mark 48 is not a bullet. It is a tethered drone. As it leaves the tube, a spool of micro-thin copper wire unspools from the back of the torpedo, and a corresponding spool unwinds from the submarine. This is the umbilical of death. This wire changes the physics of the engagement entirely. The torpedo doesn't need to rely on its own tiny eyes. It is connected to the Los Angeles-class submarine's massive BQQ-5 sonar suite, a sensor array that costs millions of dollars and can hear a shrimp eat on the other side of a trench. The American sonar operators on the sub aren't just watching, they are flying the weapon. They see what the torpedo sees. They see what the ship sees. They confuse the data. When Captain Petrov dropped decoys, his ship's onboard computer might have fooled the torpedo's local brain for a split second. But it couldn't fool the two human operators sitting comfortably in the American sub 10 miles away. This is the man-in-the-loop advantage. The wire guidance allows the firing ship to transmit mid-course corrections. If the target zigs, the operator tells the torpedo to zig. If the target drops a noisemaker, the operator, looking at the spectral analysis on his waterfall display, identifies the fake frequency and commands the torpedo to ignore it. The Soviet captain wasn't fighting a dumb circuit board. He was fighting the intuition of seasoned sonar veterans who could manually override the autopilot. However, the wire has limits. It can break. It forces the firing ship to stay relatively slow to prevent snapping the tether. Eventually, the wire is cut, and the weapon enters terminal homing. This is the moment the Soviet captain waited for. The moment the brain is severed and the weapon reverts to its own instincts. This is where the third and final revelation buried the Soviet hopes. The shift from analog to digital. In the early Cold War, torpedo logic was analog vacuum tubes and simple circuits. If sound is greater than X, turn right. It was predictable. You could trick it with a louder sound. The Mark 48 ADCAP, or Advanced Capability, introduced digital logic gating. It didn't just listen to volume amplitude, it analyzed the quality of the sound. Logic Gate Discrimination Engine. Input 300 Hz decoy versus 305 Hz hull. Action reject, input A. Attack, input B. The wizard in the lab programmed the weapon with the acoustic signatures of specific threats. The torpedo listens for the specific rhythm of a 5-bladed Soviet propeller. It listens for the flow noise of a submarine changing depth. When the Alfa released its bubble curtain, the Mark 48's onboard processor analyzed the echo returns. Object A, the decoy, was stationary with a high-frequency hiss and no engine rhythm. Object B, the Alfa, was moving at 42 knots with a low-frequency thrum and Doppler shifting. The wrong theory of the Soviets was that the torpedo would attack the loudest signal. The reveal is that the Mark 48 attacks the valid signal. It has a palette of acoustic filters. It can notch out or ignore the frequencies of known countermeasures. It effectively puts on noise-canceling headphones that block out everything except the sound of the enemy submarine. It is a hunter that cannot be distracted. The technological chasm is vast. On one side, you have the Soviet doctrine of mass and steel, giant, fast titanium beasts driven by brave men. On the other side, you have the American doctrine of sensor and silicon. The Alfa was a masterpiece of mechanical engineering. It was a hot rod. The Mark 48 was a masterpiece of systems engineering. It was a computer with a warhead. While the Soviet engineers spent billions solving the problem of how to move a ship at 40 knots, American engineers spent their budget solving the problem of how to make a microchip survive the launch forces of a torpedo tube. The result is a weapon that behaves with a terrifying insect-like intelligence. It searches in a helical pattern, expanding its sonar cone to sweep the maximum volume of water. It varies its depth to look above and below thermal layers. If it misses on the first pass, it doesn't detonate. It performs a reattack. It circles back, reacquires the lock, and tries again. You can hear it thinking. That's the scary part. You hear the ping interval change. You hear the engine RPM adjust. It's not a machine running a program. It feels like it's angry. This is the reality of the technological chasm. The Soviet captain believed he was in a contest of horsepower. He thought if he ran his engine at 100%, he would win. He didn't realize that the contest had been decided years ago in a lab in Newport by men in white coats who figured out how to make a torpedo listen to the subtle shifts in frequency that occur when a submarine rudder turns 5 degrees. The phantom that tracked the Alfa wasn't magic. It was the convergence of Otto Fuel's brute energy, the copper wire's data link, and the digital brain's cold logic. As the Mark 48 closed the final 500 yards, the wire was likely already cut. The firing ship had done its job. The torpedo was now autonomous. It switched its sonar to high-frequency update. It stopped looking for the submarine and started looking for the best place to hit the submarine. It wasn't just trying to make contact. It was calculating the geometry to detonate under the keel, where the shock wave would break the titanium back of the Lira like a dry twig. The math was done. Now came the physics. Time, T minus 30 seconds to detonation. Depth, 600 meters, or critical limit. Internal temperature, 45 degrees Celsius. Sound the scream of cavitation. Back in the North Atlantic, the theoretical physics of the Newport laboratory have manifested as a very real, very loud nightmare for Captain Petrov. The Lira is no longer a hunter. It is a trapped animal. The submarine is vibrating so violently at 42 knots that the dials on the control console are unreadable, blurred into streaks of green light. The air is thick with the smell of burning insulation and the copper tang of fear. Petrov is a student of the old school. He believes in the knuckle. Full rudder left, revert, create the knuckle. Blind it. The pilot jams the yoke. The massive Alfa skids through the water, its tail swinging violently. The goal is to use the submarine's own momentum to tear a hole in the water, a chaotic vortex of swirling aerated water known as a knuckle. To a standard active sonar, a knuckle looks like a solid object. It reflects sound. It creates a dense, noisy cloud that should act as a shield, forcing the torpedo to detonate prematurely or lose its lock. On the tactical plot, they see the green dot of the Mark 48 approach the knuckle. The crew braces for the explosion. They expect the dumb machine to bite the bait. But the Mark 48 ADCAP does not see a wall. Its digital processor analyzes the Doppler spread of the return. A solid submarine hull produces a sharp, coherent echo with a specific frequency shift corresponding to its speed. A knuckle produces a smear, a fuzzy, incoherent return caused by millions of bubbles collapsing at different rates. The logic gate in the torpedo's nose compares the return to its internal database. Result: invalid target. Classification: wake turbulence. The torpedo flies straight through the knuckle. It emerges on the other side, reacquiring the Lira in less than a second. The horror in the control room is absolute. They are throwing everything they know at this thing: speed, depth, acoustics, physics, and the machine is simply deleting their efforts. It is an unfair fight because the Soviet crew is fighting for survival, while the torpedo is simply executing line 404 of its code. It has no adrenaline. It has no doubt. It only has a time to intercept variable that is rapidly approaching zero. The Lira is now at 600 meters. The titanium hull is compressing. The pressure outside is 60 atmospheres, enough to crush a standard diesel submarine like a soda can. They have gone where no American submarine can follow. But the Mark 48 is not a submarine. It is a pressure vessel designed to operate at depths that are classified to this day. It follows them down into the crushing dark, its Otto fuel engine pumping relentlessly. Torpedo status wire cut. Mode: autonomous or terminal homing. Ping interval: continuous. The scream. Range 100 yards. Suddenly the acoustic texture changes. The wizards on the American sub have severed the wire. The Mark 48 is now off the leash. The ping becomes a continuous tone, a screech of ultrasonic energy, as the weapon creates a 3D image of the target in real time. Petrov stares at the depth gauge. He has one card left: the floor. He orders the boat to dive toward the underwater peaks of the Atlantic Ridge, hoping to confuse the torpedo with bottom returns. The Mark 48 counters with spatial gating. It knows its own depth. It knows the depth of the bottom. It establishes a floor gate and a ceiling gate. It tells its receiver, ignore any sound coming from below 700 meters or above 500 meters. It creates a virtual kill box. It blinds itself to the ocean floor and the surface, focusing its entire processing power on the slice of water where the Alfa exists. There is nowhere to hide. The end does not look like a movie. There is no slow-motion look between the captain and his first officer. There is only the frantic, sweaty reality of men realizing they have lost the technological lottery. The sound of the torpedo screw is now louder than their own reactor. It is a grinding mechanical presence that feels like it is already inside the hull. The Mark 48 maneuvers into the blind spot, the baffles behind the Alfa's screw. It positions itself for the kill, but it does not aim for the hull. A common misconception is that torpedoes try to impact the side of the ship like a battering ram. That is amateur physics. Punching a hole in a submarine is inefficient. Watertight doors can be sealed. The Mark 48 is designed to do something far more violent. It dives under the Alfa. Fuse status: magnetic proximity. Target position directly overhead. Detonation command: execute. The ocean tears open. The warhead, 650 pounds of PBXN-103 high explosive, detonates roughly 10 feet beneath the keel of the Alfa. The explosion does not immediately destroy the submarine. First, it creates gas. The warhead converts from solid to gas in microseconds, creating a massive, expanding bubble of superheated void. This bubble expands faster than the speed of sound, creating a shock wave that travels through the water at 1,500 meters per second. Water is incompressible. When the shock wave hits the hull, it hits with the force of a sledgehammer against a solid wall. But the real killer is the bubble jet effect. As the gas bubble expands, it lifts the 3,000-ton submarine upward. The entire vessel is lifted in the center, leaving the bow and stern unsupported. The titanium spine of the ship screams as it bends. Then the bubble collapses. The gas cools and contracts instantly. The void vanishes. The water rushes back in to fill the empty space, creating a massive vacuum under the center of the ship. The submarine, which was just lifted up, now falls into this hole. The center of the keel drops while the water supports the bow and stern. Snap. The structural integrity of the Lira fails. The titanium keel, the pride of the Soviet Union, snaps like a dry branch. The submarine is broken in half. Inside, the lights die instantly. The sound is not an explosion, but a hammer blow that liquefies organs and shatters bone. The arrogant Titan captain Petrov is dead before his brain can register the sound of the hull breach. The sudden change in pressure turns the air inside the sub into a diesel engine cylinder. The atmosphere incinerates. But the violence is not over. The ocean now claims its due. Depth 650 meters. Hull status compromised. Event hydrostatic collapse. At this depth, the water pressure is roughly 900 pounds per square inch. With the hull breached, the ocean enters. It does not leak in. It enters as a solid piston of water moving at the speed of a jetliner. This is the water hammer. The stream of water entering the command center hits the equipment and the bodies with enough force to shred steel. It compresses the remaining air pockets in milliseconds. The implosion is so violent that it registers on seismographs in Norway. The collapse happens faster than the human nervous system can transmit pain signals. The duration of the implosion event is approximately 30 to 50 milliseconds. The human brain requires roughly 100 milliseconds to process a visual stimulus. The crew of the Alfa literally ceases to exist before they know they are dead. They are not drowned. They are atomized by the physics of rapid compression. On the surface, 2,000 feet above, there is no massive fireball. There is no Hollywood explosion. There is only a slight disturbance in the swell, a patch of white water that boils briefly, then settles. Then the debris begins to rise. Oil, insulation, shattered bits of cork. The titanium sanctuary is gone. The Phantom has done its work and destroyed itself in the process. In the command center of the American Los Angeles-class sub 10 miles away, the sonar operator watches the screen. The screaming whine of the torpedo is gone. The rhythmic thumping of the Alfa is gone. There is a loud, dull crump sound that comes through the speakers, the sound of the ocean floor slamming a door. Con sonar, target contact lost. Breaking up noises on bearing 180. It's done. The captain of the American boat doesn't cheer. He doesn't smile. He lowers his binoculars, despite seeing nothing but the wall of his control room. He knows what just happened. He knows the math. He knows that $1 billion of Soviet engineering and 80 men were just deleted by a copper wire and a tank of Otto fuel. The unfair fight is over. The Soviet system failed not because it lacked courage, but because it lacked the bandwidth. They brought a knife to a gunfight, and they never even saw the gun. They only heard the mechanics of their own demise hunting them in the dark. Physics is undefeated. Date: present day. Status: Mark 48 Mod 7 Sea Bass. Operational record: Apex Predator. Acoustic signature silent. The waters of the North Atlantic eventually returned to their natural rhythm. The bubbles dissolved. The thermal layers drifted back into place. The ocean remembers nothing. It is a grave that digs itself. But back in the naval headquarters of Severomorsk, the silence was deafening. The loss of the titanium sanctuary was not just a tactical defeat for the Soviet Union, it was a strategic fatality. The Lira, or Alpha class, was supposed to be the future. It was the Soviet bet that physics, speed, and depth could defeat mathematics, logic, and sensors. They poured the GDP of entire cities into forging titanium hulls, believing that if they built a shell hard enough and fast enough, they could ignore the subtle art of acoustics. The Mark 48 proved that this entire philosophy was a suicide pact. It didn't matter how fast they ran, it didn't matter how deep they dove. We built a machine that could do the math faster than they could throttle the engine. We didn't defeat the submarine, we defeated the idea of the submarine. The verdict was delivered not in a peace treaty, but in the blueprints of the next generation of Soviet submarines. The Soviets stopped building the Alphas. They realized that the hot rod approach was a dead end. They quietly retreated from the titanium dream, moving back to steel hulls and focusing on silence, the Akula class. They admitted through their engineering choices that they could not outrun the American computer. The killer statistic that haunts the legacy of the Cold War underwater battles is not a body count. It is a reliability metric. In the final years of the Cold War, war game simulations suggested that a Los Angeles-class submarine equipped with Mark 48 ADCAPs had a first-shot kill probability approaching 95% against high-speed targets. Consider the economy of this violence. A Soviet Alpha-class submarine cost hundreds of millions of rubles, a massive expenditure of rare earth metals and national pride. A Mark 48 torpedo cost roughly $3 million. The exchange ratio is not just lopsided, it is financially ruinous. The United States Navy had developed a disposable robot that could trade itself for a national strategic asset. It was the ultimate asymmetry. The cheap chip killed the expensive hull. Today, the descendants of that torpedo, the Mark 48 Mod 7 Seabass, still sit in the tubes of American submarines. They have been upgraded with broadband sonar stealth coatings and processing power that dwarfs the computers that sent men to the moon. They are no longer just weapons. They are underwater network nodes capable of mapping the ocean floor and sharing targeting data with aircraft and surface ships. The arrogant Titan, the belief that brute force can ignore technology, died in the 1980s. It died the moment the first wire-guided command was sent down the tether, correcting the trajectory of a weapon that refused to be fooled. The lesson of the technological chasm is absolute. In the modern arena, there is no such thing as a fair fight. There is only the sensor and the sensed, the digital and the dead. The Soviet captains who laughed at the slow American torpedoes made the classic mistake of confusing velocity with lethality. They forgot that the fastest thing in the water is not a propeller. It is the speed of information. The wreckage of the Soviet doctrine lies rusting on the Atlantic floor, a monument to the error of underestimating the wizards in the lab. The ocean is vast, dark, and terrifying. But for the enemies of the United States Navy, the most terrifying thing isn't the water pressure or the cold. It is the realization that somewhere in that black void, a machine is awake. It is listening. It knows the frequency of your heart rate, and it has already solved the equation of your death before you even know you are being hunted. They built a wall to stop it. They never realized we would just fly over it. Subscribe for more stories from the chasm.